There is a truck that holds the Guinness World Record for the largest dump truck ever built. Not the most sophisticated, not the most technologically advanced, not the one with the most refined electronics, the largest. In terms of payload capacity, this machine exceeds every competitor from every manufacturer on Earth, by a margin that is not close. The Caterpillar 797F, the Liebherr T282C, and the Komatsu 980E all carry 363 metric tons. These machines have converged on the same payload number. For years, that seemed to represent the practical upper limit. Then BelAZ built the 75710, and the payload number changed. The BelAZ 75710 carries 450 metric tons, 450. The margin over its nearest competitors is 87 metric tons, roughly the weight of 87 passenger cars added to every single load. Built by a company that has been building large dump trucks for decades in a manufacturing tradition that developed independently. Its story, how a Belarusian manufacturer built this machine and what engineering decisions made it possible, is one of the most fascinating. BelAZ was established in 1948 in Zhodino. The plant was created to serve the Soviet Union's massive mining and industrial operations. The coal mines of Siberia, the iron ore deposits of the Urals, the open-pit operations scattered across the vast Soviet territory. This industrial context shaped BelAZ's engineering culture. The tradition valued robustness over sophistication and field repairability over precision manufacturing. A BelAZ truck was designed to work in remote mines where the nearest dealer was thousands of kilometers away. It had to be fixable by practical engineers with practical tools in practical conditions. That engineering culture is what produced the 75710, and it's why the record holder is not a Caterpillar, a Liebherr, or a Komatsu. But that's not even the most incredible part. The specific engineering decisions about the axles and tires are genuinely surprising. Every ultra-class haul truck we have discussed in this series uses the same basic axle configuration. 2 front wheels, 1 on each side of the front axle, for steering. 4 rear wheels, 2 on each side of the rear axle, carrying the drive load and supporting the payload weight. 6 wheels total. This configuration has been the standard for ultra-class haul trucks since the category was established. It is well understood, well optimized, and proven. BelAZ looked at this configuration and concluded that it was not sufficient for a 450 metric ton payload. And they were right. The math is straightforward. 450 metric tons of payload plus the truck's weight divided across 6 wheels produces a load per wheel that exceeds current tire technology. The tires would fail. Overloaded tires run hot, wear rapidly, and fail prematurely in ways that make the economics of the operation unsustainable. The solution BelAZ chose was to add more wheels. The 75710 uses 8 tires, 4 on each side, arranged in dual tandem axle configurations. 2 axles at the front, each with a single tire on each side. 2 axles at the rear with a single tire on each side. 8 tires total compared to 6 on the 363 metric ton competitors. This sounds straightforward. It is not. Configuring 4 steerable axles, 2 at the front, on a vehicle of this size is a complex steering geometry problem. Ensuring all 4 turn in coordination through curves without tire scrub requires maintaining the correct Ackermann geometry through the full steering range. The engineering of this system was one of the most challenging aspects. It required computer modeling, prototype testing, and iterative refinement. The 8-tire configuration does more than distribute load. It also provides a redundancy that the 6-tire configuration lacks. If a tire fails on a 6-tire truck, the remaining tires are instantly overloaded. The truck must stop immediately. On an 8-tire truck, a single tire failure leaves 7 tires available, a smaller proportional reduction in capacity. In some cases, this allows the truck to complete its current haul cycle and return to maintenance under controlled conditions. In remote mining locations, the ability to reach a service point can be the difference between a managed delay and a costly breakdown. Now let's talk about the drive system. BelAZ's choice reflects the same diesel-electric logic that Liebherr and Komatsu implemented. The 75710 uses 2 MTU Detroit diesel 16V4000 units, each producing 1,715 horsepower, for a combined output of 3,430 horsepower. 2 engines rather than 1. No single commercially available diesel engine produces enough power for a 450 metric ton truck. With 2 engines, the failure of one does not strand the truck. It reduces performance, but the truck can return to maintenance. Each engine drives its own generator, feeding a common electrical bus that powers the AC traction motors at the wheels. The traction motors are AC units, providing the precise controllability and thermal stability that AC drive delivers. The inverter system is sourced from established suppliers, reflecting BelAZ's pragmatic approach. Use what works, from wherever it comes. And this is where things get crazy. The 757-110's dual-engine system and 8-tire chassis produce a machine that is architecturally different. That architectural difference creates unique operational characteristics in stability, redundancy, and performance on specific grades and curves. Mining operators evaluate these factors alongside payload when deciding whether the 75710 is the right tool for their specific operation. The gross vehicle weight of the BelAZ 75710 when fully loaded reaches approximately 810,000 kilograms, 810,000 kilograms. This is the largest gross vehicle weight of any wheeled vehicle ever operated in regular service. The fully loaded 75710 weighs more than a fully loaded 797F by approximately 200,000 kilograms. This is the equivalent of more than 130 additional passenger cars added to the comparison. The empty operating weight of the 75710 is approximately 360,000 kilograms. This is larger than the gross vehicle weight of many large haul trucks. The machine is so heavy empty that most haul roads built for conventional large trucks would require structural assessment before allowing it to operate. The haul roads in mines where 75710s are deployed are specifically engineered for this machine's weight. They are built with greater compacted depth, wider dimensions, and more robust drainage infrastructure than roads designed for lighter equipment. The dimensions are correspondingly extreme. The 75710 stands approximately 8.16 meters tall, taller than any of the 363 metric ton competitors. Its width is approximately 9.87 meters. Its overall length is approximately 20.6 meters, longer than any direct competitor. That length is a direct consequence of the dual-axle configuration at front and rear, accommodating 4 axle positions in the wheelbase. The tires, all 8 of them, are the same class of massive Michelin or Bridgestone ultra-class mining tires used on competing trucks. Each stands approximately 4 meters tall. Each weighs approximately 5,300 kilograms. Each costs between $40,000 and $50,000 US. The 75710 runs 8 of them. The rubber sitting underneath the machine at any given moment is worth in excess of $350,000 US. Managing 8 tires adds proportional complexity to the tire management program, with more sensors, inspections, and more tire handler operations. The fuel capacity is substantial. Twin engines consume diesel at rates that require large onboard fuel reserves for productive operating time. The hydraulic system that controls steering and hoisting operates at pressures comparable to those in competing machines. The critical brake system uses the electric retarding capability of the AC traction motors, supplemented by service brakes for final stopping. The dump bed of the 75710 is sized to accommodate 450 metric tons of material at bulk densities typical of mining applications. The bed is raised by large, powerful hydraulic actuators that must lift the full payload weight for complete material discharge. The dump cycle time is designed to minimize the time the truck spends at the dump point, since dump time is non-productive time. A truck that dumps quickly spends more of its shift hauling and less of its shift waiting at the dump. But here is what's most important. These numbers are means to an end, and that end is cost per ton of material moved. What matters economically is whether that payload translates into a lower cost per ton than alternatives. This depends on factors that vary between operations, such as haul road geometry, bench design, maintenance infrastructure, and material type. In operations where those factors align, the machine delivers exceptional economics. Where they don't, 363 metric ton competitors may perform better. This is the nuanced reality of ultra-class haul truck selection. The biggest number is not always the best number for every application. Understanding when the 75710 wins reveals the engineering trade-offs that produced the world's largest dump truck. And those trade-offs are unexpected. The BelAZ 75710 is not a universal solution. It is an optimized solution for a specific set of operating conditions. Understanding those conditions, and the minds that have deployed the 75710, tells the real story of what this machine is for and why it exists. The 75710 was designed specifically for large surface coal mines, operations characterized by relatively flat haul roads, long push distances, and large bench areas. In these conditions, the 75710's advantages are clear. The 87 additional metric tons of payload per load means fewer truck cycles required. Fewer cycles means less fuel consumed. Less fuel consumed means lower operating cost per ton, translating directly into a significant economic advantage. In steep, complex mine geometries, like the winding, tightly curved roads found in deep copper or gold mines, the 75710's size works against it. Its turning radius is larger than that of six-wheel competitors. Its length makes navigation on tight haul roads significantly more challenging. And its weight, 810,000 kilograms gross, requires haul road construction standards that add cost where maintenance budgets are already stretched. The primary deployment has been in Russian and Siberian coal mines, where geographic conditions match the design parameters closely. The Chernigovets coal mine and other post-Soviet operations have deployed fleets that demonstrate the machine's productivity in appropriate conditions. BelAZ's engineering tradition, robustness over sophistication, produces a machine that is repairable in field conditions that would challenge other systems. Major mechanical systems are large, rugged, and designed for access with conventional tools. This is a genuine advantage in remote Siberian mines. At the same time, the electronics, like the inverter systems and monitoring computers, require specialized expertise for service and repair. The machine requires a blend of traditional heavy mechanical capability and modern electronic systems knowledge, posing a challenge in remote operations. When the first units entered service in 2014 at the Chernigovets mine, they confirmed many of the design team's productivity projections. The tire management, 8 tires rather than 6, proved more complex and costly than initial estimates, requiring adjustments to maintenance programs. Overall, the first years validated the machine as a genuine productivity tool while identifying the specific conditions where its advantages are most clearly expressed. This is the normal pattern for a new machine. The engineering is right, and operational experience identifies the specific conditions where it performs best. But the 75710's story is not just about coal mines. Its existence has influenced the entire ultra-class haul truck industry. The demonstration that a 450 metric ton payload is achievable has pushed the boundaries of what is possible in modern mining engineering. The BelAZ 75710's existence has done something important for the ultra-class haul truck industry. It has demonstrated that the payload ceiling of 363 metric tons is not a physical law. It is an engineering choice, a choice reflecting specific judgments about the balance between payload capacity, tire technology, road requirements, and operational flexibility. But a choice, not a constraint. BelAZ's decision to add axles, use 2 engines, and accept a more complex steering geometry produced a machine that exceeds the 363-ton ceiling by 24%. That demonstration has inevitably influenced the thinking at competing manufacturers about what is possible at the next generation of ultra-class haul truck development. Whether competitors will produce 450 metric ton competitors depends on market demand and whether there are enough mining operations with the right conditions. The market for this payload level is small. The conditions that make the 75710 economically optimal are large flat coal mines with long, gentle haul roads. Most mining operations involve complex terrain and tighter road geometries that favor the 363 metric ton class, but the technology developed does not disappear. Advanced AC drive systems and multi-axle steering technology inform the next generation of trucks, making them more capable, reliable, and efficient. The frontier always moves. BelAZ continues to refine the platform, incorporating improvements to electronic control systems, tire management, and drivetrain components since its introduction. The company has also explored battery electric and trolley-assisted operation concepts that would allow enormous payload capacity to be achieved without diesel fuel. The future of ultra-class haulage, fully electric, autonomously operated and optimized by AI, will build on the achievements represented by the 75710. The payload record matters less than the technology development that enabled it, contributing to a more efficient, safe, and environmentally friendly future. Visitors to the Chernigovets mine describe a moment of visual recalibration when they first see a 75710 in operation. The machine is larger than you expect. The 8 tires create a visual profile that is wider and more massive. The dual-engine exhaust gives the machine a deeper, more complex sound signature. When it begins a loaded haul cycle with its 450 metric ton payload, the scale of what you are watching does not fully register immediately. This machine exists. It works. It holds the world record. It was built in Belarus, and it carries more in a single load than any other truck. That is not a small achievement. In the history of mining equipment and wheeled vehicles, it is a record that stands alone. Next, we move to a machine that does not haul and does not excavate. It loads. The Letourneau L350, the largest wheeled loader ever built. A machine whose single bucket can fill a room, whose tires are among the largest ever. The numbers are extraordinary. And we are just getting started.